Hello everyone, this is Meenakshi here. In this video, I am going to cover the topic fragmentation. So let's see what is fragmentation. Fragmentation is an unwanted problem in the operating system in which the processes are loaded and unloaded from memory and free memory space is fragmented. Processes can't be assigned to memory blocks due to their small size and the memory blocks stay unused. The conditions of fragmentation depend on the memory allocation system as the process is loaded and unloaded from memory. These areas are fragmented into small pieces of memory that cannot be allocated to incoming processes. It is called fragmentation. Types of fragmentation. There are mainly two types of fragmentation. First is internal fragmentation and second one is external fragmentation. So let's see what is internal fragmentation. When a process is allocated to a memory block and if the process is smaller than the amount of memory requested, a free space is created in the given memory block. Due to this, the free space of the memory block is unused, which causes internal fragmentation. For example, assume that memory allocation in RAM is done using fixed partitioning. 2 MB, 4 MB, and 8 MB are the available sizes. The operating system uses a part of this RAM. Here is the diagram allocating memory block for process P1. Let's suppose a process P1 with a size of 3 MB arrives and is given a memory block of 4 MB. As a result, the 1 MB of free space in this block is unused and cannot be used to allocate memory to another process. It is known as internal fragmentation. Let's see how to avoid internal fragmentation. The problem of internal fragmentation may arise due to the fixed sizes of the memory blocks. It may be solved by assigning space to the process via dynamic partitioning. Dynamic partitioning allocates only the amount of space requested by the process. As a result, there is no internal fragmentation. Let's see second type of fragmentation, which is external fragmentation. It happens when a dynamic memory allocation method allocates some memory but leaves a small amount of memory unusable. The quantity of available memory is substantially reduced if there is too much external fragmentation. There is enough memory space to complete a request, but it is not contiguous. It's known as external fragmentation. Here is the example. Process needs 45 KB memory space. Let's understand how to remove external fragmentation. This problem occurs when you allocate RAM to processes continuously. It is done in paging and segmentation, where memory is allocated to process non-contiguously. As a result, if we remove this condition, external fragmentation may be decreased. Compaction is another method for removing external fragmentation. It may be decreased when dynamic partitioning is used for memory allocation by combining all free memory into a single large block. The larger memory block is used to allocate space based on the requirements of the new processes. This method is also known as defragmentation. Here is the advantages of fragmentation. Flexible memory allocation. Fragmentation allows for dynamic allocation and reallocation of memory, accommodating varying size of processes. Efficient space utilization. In some cases, small-sized memory fragments can be efficiently utilized, preventing unnecessary wastage. Adaptability to changing workloads. Fragmentation allows the OS to adapt to changing workloads by allocating memory based on the size of incoming processes. Let's see disadvantages of fragmentation. Reduced performance. Fragmentation can lead to slower access times as the OS may struggle to find contiguous blocks of memory for processes. Resource wastage. Both internal and external fragmentation result in wasted memory, reducing the overall efficiency of resource utilization. Increased complexity. Managing fragmentation requires additional algorithms and strategies, adding complexity to the OS design and maintenance. Role of fragmentation, memory management. Fragmentation directly impacts how the operating system allocates, uses, and manages memory. Efficient memory management strategies are required to minimize fragmentation and optimize the use of available memory. Resource allocation. Fragmentation impacts resource allocation in various processes. Internal fragmentation leads to the wastage of allocated memory in computer systems. External fragmentation creates small, unusable free memory segments in memory. Both types of fragmentation can hinder the effective allocation of memory resources. System stability. Excessive fragmentation can lead to system instability. The operating system might struggle to use memory efficiently, increasing the risk of system crashes and making it difficult to start a new application or process. Thank you for watching.